Hello students, welcome to the course Digital Electronics and Computer Organization presented by Department of Information Technology, Sanjeevani College of Engineering, Kopargaon. In this video, you will learn topic 1.6 multiplexers from Unit 1 Combinational Logic Circuit. This is the outline of the topic multiplexers. In the beginning we shall see 2:1 multiplexer, then 4:1 multiplexer, then 8:1 multiplexer, and finally Boolean function implementation using multiplexers. So let us first see the definition of multiplexers. Multiplexers, usually written in short form as MUX, are combination logic circuits which has multiple data inputs and single output. It has also select or control inputs which selects one of the data inputs and transfers its logic level or the data on the output of the multiplexer. The logic symbol of the multiplexer is as shown in this particular figure. So the definition says that a multiplexer is a device which has got many inputs. Okay, those inputs, they are called the data inputs, then and only one output. There is only one output, whereas it has got select inputs or control inputs, and the select input and control input are going to select the logic level from one of the data inputs, and that particular logic level will be transferred to the output. Okay, so this is how the multiplexer works. We shall see the different types of multiplexers. We can have multiplexers with different number of select or control inputs and output. The relation between the number of select or control inputs and the number of data inputs of the multiplexer is fixed, and it is n is to 2 raised to n, where n is an integer. That is, if a multiplexer has n number of select or control inputs, then there will be 2 to the power n number of data inputs for the multiplexer. So if we take the value of n to be 1, then we can have 2:1 multiplexer. So here this particular multiplexer will be having two inputs and only one control line, and there will be one output, whereas the 4:1 multiplexer will be having four data inputs. There will be two select lines, and there will be always one output for the multiplexer. We can have 8:1 multiplexer when n is 3. So the number of data inputs for that multiplexer are 8, number of select lines are 3, and one output. In 16:1 multiplexer, there are 16 inputs or data lines, there are 4 control or select lines, and there is only one output line. We can have multiplexers of size even greater than 16:1, like 32:1, and like that. Now let us see 2:1 mux. A 2:1 multiplexer has two data inputs, one select or control input and one output. So this is the function table of the 2:1 multiplexer. This is the block diagram of the 2:1 multiplexer, and this is the logic diagram for 2:1 multiplexer. The function table says that when S input, this particular select input, is 0, then what is output? Output is same as I0. So output is same as I0. That means when S is equal to 0, the select line selects I0 input, and whatever data is there on I0 input, it will appear on the output, that is Y. When S is 1, then this select input selects I1, and whatever data is there on I1, 0 or 1, so that will appear at the output, or that will be transferred to the output Y. Okay, so when S is 1, output is I1. When S is 0, output is I0. Now let us see with this particular logic diagram how this particular function, or how this particular logic gate will make this particular circuit work as 2:1 multiplexer. Okay, so let us say S is equal to 0. Then in that case, what will happen? The output of this inverter will be 1. Then because output of this particular inverter is 1, we know the AND rule, and because of this, the output of the upper AND gate will be I0. The input to this particular second AND gate is 0. One of the input is 0, so its output will be 0. Then this particular OR gate will OR these two as this is I0 and this is 0, so I0 or 0 is I0. Okay, so finally the output is I0. So when S is 0, your output is I0. Then next, when S is 1, then output of the inverter will be 0. As a result of it, what will happen? The output of the first AND gate will be 0. The output of the second AND gate will be I1, because this is 1. One of the input is 1, so the AND gate I1 and 1, it will be I1, and this particular OR gate will OR 0 and I1, and that will be I1. So the output of this particular circuit is I1. So this particular inverter, this particular circuit, it works as 2:1 multiplexer.